Okay, welcome to part C of lesson 1 of the topic vectors in our series. This is a continuation of part B, so if you have not viewed part B, do well to view it, as the link to part B is in the description of this video. Also, do not forget to hit the subscription button and the like button so that you will always get alerted anytime new lessons are updated. Alright, in part B we talked about vector representation, and then we saw the notations that we shall be using throughout the remaining part of our discourse on this topic. So in this part C, we'll be talking about the concept of the resultant vector. Okay, two or more vectors acting at a point in any given number of directions can be combined to give a single vector known as the resultant vector. Now, vectors generally act at points or on objects. Okay, if you have a force acting on a load, the force is the vector quantity, and then the load is the point of action. Why are we talking about this? It's possible for you to have 2, 3, 4, or 5 forces acting on a load. How will you know the actual force that that load is responding to? Another case is that you may have a swimmer or a boat trying to go across a river. The swimmer has his own velocity, and then the river has its own velocity. So how do you know the actual velocity that will control the swimmer or the boat, as the case may be? This is why we'll be looking at the concept of resultant vector. So a resultant vector is that single vector that is obtained from the appropriate combination of any number of vectors and will have the same effect in magnitude and direction as the original vectors acting together. Okay, so what we are saying here now is that in a situation where you have more than one vector, or 2 vectors, 3 vectors acting at a point, those vectors could be combined appropriately to get a resultant. So the single vector that you obtain from that process is what we call the resultant vector. Now, something is very important to us here. In getting a resultant vector, you don't just combine the vectors anyhow. There is need for appropriate combination. So that suggests that there are factors that will bring about this appropriate combination. One of those factors is to know the number of vectors involved, and secondly is to know the relative directions of these vectors with respect to each other. We've talked about the concept of magnitude and direction of vectors being represented with straight line in part B. Okay, so the number of vectors acting at a point and then their relative directions with respect to each other are two important factors that will help us know how to appropriately combine vectors in order to obtain their resultants. Let's quickly have a rundown of some of the cases. Now, if you have a single vector acting at a point, let's assume this is the single vector, vector P. Okay, the resultant vector in this case is going to be equivalent to vector P. So this suggests that where you have a single vector acting, the resultant is going to be equal to that vector. Okay, then you can have 2 vectors acting. Now you can have our point of action. You have the first vector acting towards the right in this manner, vector P, and then you have vector Q acting in the same direction. How do you now obtain the resultant? Now, these vectors can be acting in opposite directions as well, beg your pardon, or the vectors may be aligned to each other at an angle. Maybe you have Q in this manner and then you have P in this manner. So how do you obtain the resultant in these cases? You can see that here 2 vectors are acting at a point, but getting our resultants, the approach we are going to use is not going to be the same because of the relative relative directions of these vectors with respect to each other. Okay, you can also have more than two vectors acting at a point. So these are some of the things we are going to be seeing subsequently in our lessons. Anytime you want to obtain a resultant vector, the first thing you should consider is what are the number of vectors, what is the number of vectors involved, and secondly, what is their relative or what are their relative directions with respect to each other. So this brings us to the end of lesson 2. Sorry, I beg your pardon, part C of lesson 1. And this also brings us to the end of lesson 1. So from lesson 2 of the topic vectors, we'll begin to consider how to get the resultant vector in more details. We'll talk about the triangular law of vector, we'll talk about the parallelogram law of vectors, we'll talk about relative velocity and how to sum vectors. So do well to hit the subscription and the notification button so that you can get alerted anytime new lessons are updated on this channel. Thank you very much. See you in the next lesson.